Hi, Team Learn at Home. We started class today with a bit of a confession on my part. I had a truly disgusting evening. I spent 180 minutes eating pizza. And the pizzas, they were cut into 12 slices each, but I managed to eat 42 slices of pizza in 180 minutes. So I have some questions for the class to get us started. How many hours was I eating pizza? How many whole pizzas did I eat? And how many minutes did it take to eat a single slice? Like, what was my rate of pizza consumption? So let's take a look at how we can do this. All right. So when I asked this, a lot of people told me, well, 180 minutes. You'll want to answer that yourself. If I go around the clock, 180 minutes. How many hours is that? And they told me that's 3 hours, Mr. Jennings. Good. Now, here's how we can use fractions and what we've been doing to do that. I can put the big number on top, 180 minutes, and I'm going to divide that by 60 minutes, saying how many hours is in that. That's an hour, but written in minutes. And then, if you just said that's 3, that's correct. But we can also write 180 a different way. We could write that as 3 times 60. And that would be over 60 still. So I haven't changed anything. I just wrote it a new way. And then we get out, this is the fun part. This is the funnest thing in math. Canceling. So this 60 cancels that 60. Leaves us our answer there, 3. All right? So nice. Now, why is that? Well, imagine what would have been the situation if I was eating pizza for 60 minutes and then I said, how many hours did I eat that pizza? 60 divided by 60, that's 1. That's 1 hour. Okay? So that's really useful idea. This is just written another way, 3 times 1. 60 over 60 is just 1. So that's why it's 3 hours. And when we cancel, they go away and they leave 1. This is not 0 on the bottom. This is 1 on the bottom. Okay, that's important. Now, let's use the same logic to see if we can figure out how many whole pizzas did I eat. But first, make your guess. If I ate 42 slices and the pizzas were in 12 slices, about how many pizzas is that? Is that 2 pizzas, 3 pizzas, 4 pizzas, 10 pizzas, 42 pizzas? No, it's not 42 pizzas. I can't eat that many. So let's see. If we zoom in here, we're going to take these numbers, answer this question. Whole pizzas did I eat? Well, I ate 42 slices, and there were 12 slices per pizza. So now let's write 42 another way. I'm going to do that up here. 42, and I'm going to write 12 another way. Okay, 12, I can write that as 2 times 6. 2 is prime, 6 is not. 6 is 2 times 3. Both of those are prime. So I can write 2 as 2 times 2 times 3. Or I could have written 2 squared as well. Okay, and then 42, let's see how that breaks down. It's divisible by 2, that's prime. And 42 divided by 2, that's 21. 21's not prime. It's not divisible by 2, but it's divisible by 3 because 2 plus 1 is 3. 3 is divisible by 3, so this number is divisible by 3. 3. And I multiply 3 times 7, and 3 times 7 will give me 21. That's very clearly a 7, Mr. Jennings. All right, so let's write that as 2 times 3 times 7. 2 times 3 times 7. Okay, cool. Now, I'm going to get my canceling pen out, my favorite pen to use. And I can see I can cancel one of these 2's on the top and one of these 2's on the bottom. I can cancel this 3 on the top and that 3 on the bottom. And I'm left with this equaling 7 over 2. The last things that are left are my answer. Okay, 7 divided by 2. This is the number of pizzas I ate. How many pizzas is that? Written another way, that's 3 and 1/2. Okay, 3.5 pizzas. Or another way, 3.5. Your calculator will tell you that's 3.5. Okay, so that's how many pizzas I ate, 3.5 pizzas last night. Now, let's see if we can figure out how many minutes it took to eat a slice. Okay, I ate 42 slices. And oops, I don't want to do that there. Let's move my face, which is in the way. Eraser. Okay. Okay. And let's get my pen back. I'm going to put 42 on the bottom here because I want to know how many minutes per slice. So that means I put the number of slices on the bottom and the number of minutes on top. I also know just by looking at this, I should get some like number of minutes to eat a slice that's like bigger than 1. I'm not eating one slice of pizza per minute or faster. It's going to be slower than that. There's way more minutes than there are pizzas. So now let's write 42 in a new way. It's 2 times 3 times 7. I got that here. And 180. I don't have to factor it all the way. I just want to see what can cancel. It is divisible by 2 because it ends in a 0, 2, 4, 6, or 8. It is divisible by 3 because 1 plus 8 is 9. 9 is divisible by 3. Therefore, 180 is divisible by 3. So I can write that as 6 times, what is it? 6 times 30. 6 times 30 will be left. All right? And now I can get my cancel pen out. And this 6 would cancel this 2 and that 3 because 2 times 3 is 6. So 6 over 2 times 3, that's just 1. So my answer here is 30 over 7. We got that answer and we said, that's pretty ugly. We don't really know what that means. How do I interpret that answer? This is how many minutes it takes me to eat a slice of pizza. But what does that mean? Well, if you had to guess, you might say that looks like about, 4 or 5 minutes, and you'd be right. Okay, and this is why. 30 could be written as 28 plus 2 over 7. 28 over 7 is 4. And so this is 4 and a little bit, 4 and 2/7 of a minute. So it takes me maybe like 4 and a bit minutes to eat a slice of pizza. Is approximately equal to 4 minutes. Yeah, there we go. So that was some things we learned about my evening. Okay, pretty gross evening. So one of the things that we discovered when we worked on the work today is when we have a number, and let's take another one. Like if I have, say, 70, let's get a pen here. That'll be useful. 72, and I'm dividing that by another number, let's say 18. Okay, and I want to reduce that fraction. Let's express 72 as a product of its power. So I'm going to do a factor tree. 72 is divisible by 2, gives me 36, is divisible by 2, gives me, there it is, 18. Okay, I have a pretty easy one here. That's too bad. Let's change this to 16. Oh, Mr. Jennings, you should prepare these ahead of time. 16 will be much nicer. Okay. I kind of knew what I was getting into, too. I knew this was going to happen. So 18 is divisible by 2. It's 2 times 9. And then 9 is not divisible by 2, but it's 3 times 3. So I know that's the blue pen. Go away, blue pen. All right. And so here, let's circle our primes. 2 times 2 times 2 times 3 times 3. That shouldn't surprise us. It's 8 times 9 is 72. So I can write that as 2 to the 3 times 3 to the 2. Divided by, 16, let's do it. Let's do a factor tree for 16. It's divisible by 2, that gives me 8. It's divisible by 2, that gives me 4. 4 is 2 times 2. So this is 2 to the 1, 2, 3, 4. 16 can be written as 2 to the 4. And then if I want to reduce that, I can cancel. But how do I do that? Well, when we see these exponents, we might get confused. So I'm gonna leave that there. I'm gonna bring my canceling pen back to it in a second. I'm gonna write it in a new way. 2 times 2 times 2 times 3 squared. We'll leave it that way. Over 2 times 2 times 2 times 2. And now I get my canceling pen out. This 2 cancels that 2. This 2 cancels that 2. This 2 cancels that 2. These cannot be canceled. I can't cancel that 2 with that exponent. That's 3 times 3. That has nothing to do with the number 2. It's just 3 multiplied by itself twice. Okay? So this is actually equal to 3 to the 2 over 2. This is equal to 9 over 2. That's what this is equal to. Let's see if we can do our canceling here. This is 2 to the 3. This is 2 to the 4. So I'm going to cancel that whole thing. And I'm going to take 3 away from that 4 and make it 1. So 1 2 is left over. This is what I'm left with. 3 squared over 2. So it's very fast to reduce these fractions when you use factor trees and can think of the numbers in different ways. Okay, so now let me direct you to the work from today that we did at the whiteboards. You can try this work yourselves. So you'll find it under the content tab in our class. You're going to scroll down past Unit 0 to Unit 1. You'll find my previous lessons from the other days. You'll find this lesson next to this after I push finish record. And here are the questions that we worked on. You'll find that you will hate me if you don't do these with patterns. If you do these with patterns, you'll find they're very smooth. Okay, so practice doing the patterns here. Practice with these numbers and expanding them. Are those numbers those things? Then try reducing this fraction using the factor trees. Okay, evaluate these things and see if you can do some canceling. Okay, if you need a review, let's do a quick review. We'll do an example of how we multiply fractions. We did this yesterday in Delta Math. And what we noticed was when we multiply, let's say 3 over 4 times 5 over 6. See how fast I can make these examples? Ha ha ha. Okay, this would be equal to 3 times 5 on the top over 4 times 6 on the bottom. Top times top over bottom times bottom is how you multiply fractions. Now I can do canceling. Let's write 4 and 6 in new ways. 3 times 5 over 2 squared times 2 times 3. 2 squared is 4. 2 times 3 is 6. I could write that as 2 cubed, but I don't care. I see that the only thing's going to cancel. I guess green is my cancel pen. That cancels, that cancels. So I'm left with, this is equal to 5 over 8. That's beautiful. It's Fibonacci. Okay, cool. So that's how you do it, right? That's how you multiply your fractions. As you get working with your fractions, you'll start to see patterns. And I want you to use those patterns and apply them to the following questions. And if you don't see the patterns, that's also why I'm here, to help you see them later. Bye for now, everyone. Hope your math practice is fruitful today. Any questions, hit me up by email.